We are starting to wrap up this chapter 2. We're going to solve this problem, and I think we'll stop there. While we do have more to talk about, I'll show you maybe some of this on tomorrow, but the crucial stuff we'll end with today. So let's practice this problem about cholesterol. Maybe a little depressing of a story or context here. So I guess cholesterol follows a normal distribution with a mean of 170 and sigma of 30. So let's start with that. X, or you can write cholesterol, is normal with a mean of 170 and a standard deviation of 30. They want to know what cholesterol level represents the first quartile. So this is a backwards problem. I want to know what X less than something equals 0.25. So there's my question. You don't have to write this part, but I'm going to write it so you know where it came from. Inverse normal. Remember, the area is the left area. It's the, what would you call it, upper bound area. So 0.25. Another word for area would be percentile. I'm going to leave mu at 0 and sigma at 1 because it's a free response and I got to show my work. So when I do that, I get a z-score of negative 0.67. And I'll show you firsthand if you don't know how to do that. So we go to menu, stats, distributions, inverse normal, 0.25. And that's it. Negative 0.67. Now, if you kind of want to cheat and see what your answer should be, you can get an answer kind of close. So change that to 170 and this to 30. Now be careful, your answer is going to be a tiny bit different than what this is about to tell us, because they're using the super precise z-score when you hit OK. We're about to round it when we do our math to negative 0.67. So our answer is going to be a little different from this, and you want to be careful with what you write, because if you write that z-score, then the x you get is not that x. You want to be consistent with what you're writing down, all right? Once again, they're using a super precise z-score when you type it outright like this. And technically, this is actually more right than what we're about to write down. So when we write it down, we're going to go negative 0.67 equals x minus 170 over 30. We'll multiply both sides by 30, and we get negative 20.1. Oops. And when I add 170 to both sides, I end up getting a cholesterol level of 149.9 milligrams per deciliter. So notice that's a little bit different than what I just displayed on the calculator, but know that our answers are okay. They're very, very close. It's all because we rounded this number right here, and that's okay. All right, so minimal, to get full credit, I need to see this, I need to see this, this, and this. Some people, instead of the question, they like to write this stuff here. But I don't know, that's up to you. I prefer that way. All right, let's work another one. 92nd percentile. I already defined the distribution above, so now I just need to write the question. What X's fall below what cholesterol level? Or I should say, 92% of X's fall below what percentile of 92? So I jump to inverse norm, and I type in an area of 92, and I get a z-score of 141. Plug it into my z formula. And solve for x. I get 42.3. And lastly, I get 212.3 milligrams per deciliter. I need to see the answers, some work, and the question. All right. There is a very backwards problem. We'll practice that tomorrow. So if you need a sneak peek, it is right here. This is a good practice problem. Sometimes they show up like this on multiple choice. We'll practice that tomorrow. All right. See y'all later. Bye.